Suppose you were asked to convert a DFA to a C code. The DFA is supposed to recognize a string such as nano. So let's assume that we wanted to find a way to create a DFA and then convert that to C code. What is this DFA supposed to do? It's supposed to recognize, the string nano or pattern nano in any text that you send. So in order to write this machine or DFA, what we're going to do is we're going to use states, which is how the DFAs are done. And so we will have a start state. So in the start state, what we like to do is if you get the character n, you would move to the next state. Let's call that the start state n. Now from here, if you get the character a, you would move to the start NA. This means that you have seen the string NA. From here, if you see another n, I would move to the state NAN. If you see an O, I would move to the state NANO. So this becomes my accept state. Now, so I did all the transitions from one state to another based on character that's been recognized. Now, suppose the character you got is not an n. This means that you must wait. So let's say tilde n means it's not an n, and you have to wait in the start state until you get another character. At this point, you're in the state n. If you get another n, you can stay there. If you get another n, you will stay in that state. And if you get an a, you will go to NA. And if you get another character other than n or a, you must go back to the state start. So I'm going to say that's neither n nor a, and I'll go back to that state. When you're in state NA, if you get an n, you will go to NAN. But if you get anything other than n in this state, there's nothing we can do other than to go back to the start state. So the not n means I will go back to the original state. When you're in NAN, if you get an O, you would go to the accept state. If you get an n, so what you can do is you can go to the state n. So if you get an n, you would go to the state n because you have seen an n, so you don't have to go all the way back to start. You can start from the state n. If you see an a, that means the reason you're here is that the last character you saw was an n, and if you see an a, you can go to the state NA. So if you see an a, you know that you have seen the last character n. Now you saw another a, so this means that you have seen NA. And this is our DFA. And so what we need to do is to convert this DFA to C code and see how this is going to work. The idea is that this machine is going to keep accepting things from an infinite string that's coming in until the end of file. Now after you get to the accept state, you can also return back to the start so if you want to recognize more strings, you can return back to the start and start this thing all over again. So technically we build this machine and we can send an infinite string through that. So this is our machine, and we send the input string through this machine, and then we will get whenever the accept is, we will get a message. And if you don't get a message, we assume that the string was rejected. So what we're going to do is we're going to figure out how to code this into a C. And one thing that's important to know is that this diagram that I created is really exactly the textual representation of this diagram is given here. You start with a start state. If it's an n, you go to n, and if it's a If you're in N, you have few choices that you will go back to A or NA and so on. One other thing that I did not do here is that in this case, if you see something other than, let's go back here, you see something other than N or O. So we have A is fine, N is fine, O is fine. But if you see anything other than that, you should go back to the start state. So this means that it's not N or A or O. All right, so this is my graphical representation, and here's the textual representation of the same machine. Okay, so now our goal is to take this DFA, or the textual representation of the DFA, and convert that to C code. Now, before we do that, we have to understand what a DFA is. So a simple definition of a DFA is that you have a set of states. One of them may be the accept state or more than one. And then you have a transition function that's when you're in a certain state and you give a certain character, it takes you to another state. So the transition function is given by this. So if you take any of these things, states, you can think of a state as a transition thing. So suppose you're in state N and you got the character N, you're going to go to state N. If you get the character A, you're going to go to state NA. So think about the state as a function, and then you can organize your code accordingly. So let's get started with the code. So in this case, I'm going to create a file called nanodemo.c. And it's an empty file, so I'm going to start typing something. So include standardio.h. All my programs need standard IO. Now, one of the things you have to think about is how to represent states. Now, one of the features of C is that you can use enumerated types, or enum. So I'm going to give it a name, and then I will have all my states in that. So it's start, N, NA, NA, N, and NA, NO. Those are the states I want to work with. Now put a semicolon there. Now, if you're wondering what enum is, enum really defines a type called state, but it can only assume these values. In fact, these are really integers, but we use text to represent them. So you can think of this as 0, 1, 2, 3, 4. So I can represent any kind of a variable of type enum state. So that's what I'm going to do. And so in order to get started, so let's just say I'm going to define a variable of type state called state. Okay, so state, and I will initialize that to start. And now I need functions to represent all of these states. Now, as we know, a function is something that's in a state. You take a character and you go to another state. So I'm trying to represent that. So this means that the return type of the function, because you have to return to another state. Think about a function, you can say the function output is another state. You're in a certain state, you take a character, and the output is another state. So we're going to say enum state. This is my return type, and we have a function called start, and it'll take a character as an integer, and so I'm going to write a function prototype. So I'm going to write the other things similarly. N, function N, and int C, and then I'm going to write enum state, function NA, and int C. So all of them take a character and go to another state. Enum state, function NA, NAN, int C, enum state, function NA, and O in C. So those are my function prototypes. Now I'm going to write my main program with the style that adapted from essentially from the slides. So the idea is that we would read a character. So I'm going to read a character. So I'm going to have a variable called C. All right, so now we define an integer c. Now what we need is a loop in the main program, so let's call it a while loop that will take characters as long as those characters are not in the file. So what I'm going to do is I'm going to show you a very nice trick to not have a separate statement but get the character inside the while loop. So what we're going to do is we have a c, which is an integer, so we call get character, and that returns an integer. And then what we're going to do is we're going to typecast that to be a character type, so that's good. And then we'll compare this to the character in the file. So what I just said was a very powerful statement, which says that let's call the get character within the while loop. So it executes that, returns a c, which is an integer. And once I get those two, then I'm going to convert that to cast that to a character type. I'm not converting anything. And then I will compare it to the end of file. So what I like to do is to run my code until I hit the end of file character. So inside this loop, what I like to do is to convert these definitions into code. So for instance, I may say something like this: if state. Notice that the state was defined as a enum state type. The state is a start. Then what I like to do is the state is a start, and let's convert this to and you have a character start. You have a function called start. You have a function called start, which is here. Okay, and then we provide this character we just got to the start. So this is like you're trying to get the transition function. So in other words, my function start, which I'm going to write in a little bit, will have to do the right thing. So it has to build this logic into that function. So it takes the character c and call the function start, and then it's supposed to return, notice that the start is supposed to return a state. So I want to get the next state from that. So this is directly related to the function definition I wrote. You're in a state, and give me a character, I'll go to another state. That's my return type. So now let's go, and I can do the other things similarly. Else if the state is the state that the next state, which is going to be n, and I will do something. So I'll get to that in a little bit. All right, so this is the end of the file. Okay, let's go to that. And now I'm going to, that's the end of the while loop. And then now it's going to be the end of the main program. Now here, what I'm going to do is I'm going to write my function. So I'm going to start by writing the start function. So I know a start function is a function that takes a character as an integer and then do something with it and return, in this case, return a state, some other state. So it takes a character and go to another state based on logic. So how do I bring the logic? How do I build the logic? So I'd say if the typecasted c, which is a character, is equal to n, then I want my state to be n. So I'll go to state n. Now notice that is the same as what I'm saying here. And otherwise, that means otherwise is here. I will let my state be the start state. And then at the end of this function, I have to return a state variable. So I'll return the state variable here. So this means it'll be returned to the main function. So in this case, if I give a character, and if that character happens to be n, my state will be set to the end state. So I'll be going to the end state next. All right, so this is how we're going to get started, and I'm going to show you next the rest. All right, so now I'm going to show you the completed code for building this entire machine. My goal is to build this machine that recognizes the nano. So last time we did all of these things, and I had state is a start character C, while we go to the next state. So it's pretty easy. If you're in state n, its logic looks the same for all the states. You're in a state and you get a character, you have to decide where to go next. The logic actually come from here. So we wrote this part of the thing before start how this code is converted. His textual representation is converted to code. Let's take a look at the state n. So the function n takes in its c and then returns an enum state. Now keep in mind that when I'm writing this, I'm not following all the styles because I don't worry about it right now. I'm just trying to get this done. Um, and so the basic thing you have to understand is that how this code works. So like, for example, this state, if you get an n, then you go to state n. If you get an a, you go to state na. Otherwise, you go to the start. So I return the start. Oops, I made a mistake here. I guess all right. So now the same thing with the state na. Notice that if I get an n, I will go to start nan. Otherwise, I will go to the state start. If I get an na, if I'm in the state nan, if I get an o, I will go to nano state, or get an n, go to n state, or otherwise go to na, or and then at the end return the state. So the state nano is really an accept state. So for instance, if I get to the that, then I'll go back to start. The reason I want to do this is to make sure that I'm going to look for all the patterns. Otherwise, I could just return from the function at this point or main program at this point. So this is pretty much your code. And let's see how this code runs. And I will open up let me save this code, and then I'll say GCC 217 nano demo.c. So it does work fine. Now I have a bunch of files I've prepared prior to making this video. So one of them is the nanotext2.com. So let me show you nano. These are some of the input file I will try to use. Nanotext2.txt. So it shows you the nanotext. So it says this is a test that contains the text. It should be text. It contains the pattern nano. So it should find this. And sometimes the pattern is not exactly nano, so it shouldn't find this because there's a blank between the letters. I want my DFA to recognize any number of nano patterns. So this means that this should be recognized too. Although it's in quotations, the pattern is there. So it'll see the pattern. So let's see how we're going to run this. So I did the compilation before. So this is will be written to an a.out. So I'm going to say a.out, and I'm going to give the nano text 2.text. And it found two patterns. Now, if you recall, nanotext has nanotext2 has two patterns. Now, if you look at the no nano.text, it doesn't have anything in there. So I'm going to try to see if it's going to be correctly working. If I give no nano.text, it prints nothing. This means the pattern is not found. So basically what I did was, let me go back to my code here. So I have a nano demo.c. Oops, I should go back to an Emacs window here. Okay, so this is my code, and the code correctly recognizes all the nanos if they exist, and it returns nothing if there's no nano pattern. So hopefully this is helpful, and this is just an example of building a DFA to recognize a pattern and then writing the C program to accomplish that.